Solving equations. We're going to take your skills further this week, and the task is to be able to solve more complicated equations with variables at both sides and also brackets by the end of the week. If you have a look at the scales below, you'll see that an equation means that two things are equal. A pair of scales show both sides balanced and are equal. The scales below on the left-hand side have 2 bags of x and 5, and this is equal to 21 on the right-hand side. We know it's equal because it balances. That means that if it's 2x plus 5 and 21, the next thing we can do is set up an equation. So if 2x plus 5 equals 21, how do we solve it? The first thing is you'll see that we've got marbles on both sides, so we could take 5 off of each side by removing 5. If you remove 5 from both sides, then you'll be left with 2x equals 16. And then if you know 2 bags have got 16, then what would 1 have? 8. So remember, whatever's beside it, you divide by. You can always check. 2 times 8 plus 5 does make 21. Okay, here we've got 3 bags of x and 6 marbles, and on this side we've got 21. So what could we do? We could set up the equation, and if we have plus 6, then what we could do is remove 6 from both sides. So if we take 1, 2, 3, 4, 5, 6 off of both sides, then we're left with 3x in one side and 15 in the other. How many 3's make 15? 5. You can check. 3 times 5 is 15, and if you add 6, you do get 21. What do we do to one side? We must do to the other. So if we say add, then we know we subtract to the other. If we say times, then we'll divide. So here, if we have minus 5, we will add 5, and that will give us 8x is 16. How many 8's? 2. If you see minus 17, add 17. Be careful about this. 17 take 2 is 15. How many 5's? 3. Add 7, take 7. That leaves you with 2x equals 4. How many 2's make 4? 2. Plus 6, minus 6. Be careful because we will have integers and we'll have fractions at times as well. This goes to minus 7. So how many 7's make minus 7? How many 7's make 7? 1. So plus and minus, minus 1. And then plus 1 means take 1. So if you take 1, you get 4. Now, what do we do normally? Here, we said how many 8's made that. So what it meant was we divided by 8. We divided by 5. We divided by 2. So here we're going to divide by 3. It's not necessarily the prettiest, but we have 4 over 3. And it's fine to leave it like that. More complex equations that we're going to deal with now have letters and numbers on both sides. So we're going to explore that in the next stage. This time you'll see we've got bags of x on both sides and marbles on both sides. So this time we've got 2x plus 5 and x plus 10. So if they balance, we should be able to set up an equation. So how do you deal with this? If you've got 5 extra on both sides, then you could get rid of the 5 first, okay? What would that leave you with? You've still got 2x in this side, but you've got x, and now if you've taken 5 off of both sides, so you'll see I had plus 5, I take 5, and then I end up with 2x equals x plus 5. After that, there's 2 ways to think about this. If you have x, you can take x, or you can think how many more x have you got on that side. Take x off of both sides, take a bag away, and you're left with x equals 5. 2x plus 6 equals x plus 9. So what do we have there? We could remove 6 from each. And then we're left with taking 6 off. Because it's plus 6, take 6. You're left with 2x equals x plus 3. Then what do? We remove a bag from each side. So if we take an x off of both sides, then we're left with x equals 3. We don't have pictures all the time, so we have to think about how to cope with this. So let's go through. We solved our equation. I'm going to show you 2 ways to do it. You're not going to have set scales all the time, and it doesn't matter whether you move the number first or the letter first. It's entirely up to you. Whatever you do, you have to think about add with subtract and times with divide. So let's do the same question twice, just to remind you, you have options. So what we could do first is subtract 6 from both sides. Take 6 off of both sides, you're left with 2x equals x plus 3. Then take x off of both sides, and then you're left with x equals 3. That's the way we did it a moment ago. But you could move the x's first if you want. So you could take x off both sides first and be left with x plus 6 equals 9. And then take 6 off of both sides and be left with x equals 3. Get the same answer. We actually take x off and take 6 off both. It's just the order. Personally, we usually go around moving the number first, but it doesn't matter. It makes no difference whether you do the x's first and the number second or vice versa. So let's have a look at this. I'm going to move the minus 5, so I'll plus 5 and that will make it 16. Then I'll take 6x off of both sides, so that will become 2x equals 16. How many 2's? Divide by 2, 8. Okay, bit tougher. Minus 17, so I'm going to add 17. Oh, sorry, I'll just reverse in that. Forgot what I decided to do. I've decided to change it around, so minus p, so I'll add p. If you add p, that becomes 5p. Then you can add 17. 17 onto this will take it to 15, just because it's like 17 minus 2. And then how many 5's? 3. Okay, in this one here, it's up to you if you want to move the 5 first or the x. Let's subtract x from both sides first. So if you take x off, you're left with 2x. Then let's add 5 to both sides, and you're left with 7. You might not always get a nice answer. You can do 7 over 2, or you can say if how many 2's make 7. You can have a decimal as well, or you can have a fraction, 3.5. Okay, what would you like to do here first? Let's subtract 3q from both sides. That will leave me with 4q plus 6. Then if it's add 6, let's take 6. And then how many 4's are in 4? So it doesn't matter whether I move the letters or the numbers first. That is your choice. Okay, your first task is to try these questions. You'll find they're available on the PDF, and when you're finished, then you can check your answers on the PDF that says Task 1 Answers.